rich site. So these are electrophiles are nothing but these are electron deficient centers, and they will have affinity towards electron rich site. What about nucleophiles? These are electron rich center or electron rich species. Electron rich species or center. These will have affinity towards which attacks on electron deficient site. So these are the two things we have to remember always when we are going to study about the chemical reactions in case of organic compounds. So these electrophiles, they are electron deficient and they attack on electron rich site, whereas nucleophiles, they are electron rich centers and they attacks on electron deficient site here. So in case of this, here the properties of alcohols can be classified into two categories. One, that is we are going to study here, reaction involving cleavage of OH bond. So first one is reaction involving cleavage of this OH bond, and another type is there. So reaction involving here this cleavage of CO bond of alcohol. So these both the categories we have to see in detail what happens when there is a breaking of this OH bond. So generally we write these alcohols as a general formula ROH. So we write this as ROH. So breaking of this OH bond means cleavage or breaking of this bond, OH bond, it will form two species here, that is it will form RO minus plus H plus, because the pair of electron which is formed here between these bond, it has taken by this oxygen, and hydrogen, this without electron, it easily gives this H plus. So this shows the acidic character of a alcohol. So it shows that alcohols are acidic in nature, acidic character, or they are having acidic nature. Alcohols are weak, slightly acidic. Why they are slightly acidic? Because it will, if there is a breaking of this OH bond, it will give easily a this is called as deprotonation, and it will form this RO minus and H plus. So here this breaking of this OH bond, this shows that here in case of this, when there is a breaking or cleavage of OH bond, here alcohol here behaves as nucleophile. In case of this, it behaves as nucleophile, and when there is a breaking of CO bond, which usually we write alcohol this as breaking of this ROH, breaking of this bond, it is nothing but CO bond. So R is nothing but alkyl group. So if I take primary alcohol, so this will have this hydrogens and this OH bond. So breaking of this bond, so it is possible, breaking of this bond is possible here with the protonation. First step is here, protonation is mandatory. This protonation is mandatory when we are showing a breaking of CO bond. Otherwise this OH group, it will not remove, it will not go as a leaving group so easily. When there is a protonation, it will be converted into a protonated alcohol, and this leaving group, it will go as, or it will removed as a water molecule, that is neutral water molecule. So here lone pair will attack this proton, and it will form here this is called protonated alcohol. And this protonated alcohol, now this group is OH2, this is easy leaving group, and this to neutralize this positive charge which is formed by the donation of this lone pair to this proton, it will neutralize, and there will be breaking of this CO bond, and it will give us RCH2 positive. So it will show a positive, that is carbocation formation, and one neutral molecule, that is water, will be removed. This OH will be removed in the form of water molecule, just because of this mandatory this protonation step. Here this is a formation of carbocation. So here alcohol, in this reaction, this alcohol reacts as a electrophile. In case of this, when there is a breaking of CO bond, here in this type of breaking, alcohol behaves here as a, alcohol behaves like electrophile in this type of reaction. When there is a breaking of carbon and oxygen bond, when there is a breaking of oxygen and hydrogen bond, here alcohol will behave as a nucleophile, because it will have a minus charge, that is electron rich center, but here alcohol will have electron deficient center. First we are going to see now about acidic nature of this alcohol. Acidic nature of alcohols. So here reaction with active metals, reaction of alcohol with active metal, reactions with active metals or alkali metals, that is group 1 and group 2 of a periodic table, they are called as active metals. And here I will write this reaction of alcohols in this with these metals. So usually for example sodium, potassium, magnesium, calcium, or sometimes it will be aluminium. So just reaction of alcohol with these metals shows the acidic nature of alcohols. Acidic nature means there is a dehydrogenation. When these metals reacts with alcohol, they will remove hydrogen, that is H2 molecule, and this is called as dehydrogenation reaction. Dehydrogenation means removal of hydrogen. When alcohol reacts with these alkali metals or active metals, there is a liberation of hydrogen, that is H2, and it shows that this formation these are the having this acidic character. So how it is having acidic character? For example, alcohol we write it as ROH. So here it will have minus charge and this will have positive charge because of electronegative difference. Oxygen is more electronegative and hydrogen is electropositive. When we add any base usually it will be electron rich, it will have a lone pairs, it is electron donor, base is electron donor, so it will have electron rich center. And alcohol here, when it reacts, suppose this is acid, it acts as acid, when it reacts with the base, it forms this minus charge, it will abstract this proton, this is base, so this will abstract proton from this alcohol, and there is a formation of BH and this RO minus here. So this is a breaking of OH bond here. It shows acidic character, and this is acid, and this is this is base, and this is a conjugate acid of that base. And if it is acid, so this is the conjugate base for this acid. So according to a Bronsted and Lowry concept of acid bases, so this is a conjugate base, and this is a conjugate acid for this conjugate base, and this is base, and this is a conjugate acid. So this shows that it is having acidic nature. These alcohols are having slight acidic nature. So how, just I will take one example. When this alcohol, that is ROH, when it reacts with the sodium, here I am taking this sodium metal, it will give us, there is a sodium alkoxide formation plus, if we want to show a dehydrogenation, that is removal of hydrogen, so there should be a 2 alcohol molecules and 2 sodium will form here to this sodium alkoxide, and here it is the liberation of this hydrogen gas. So for example, this is a general reaction, and we are going to see here one particular reaction with ethanol. So ethanol, that is 2 molecules of CH3 CH2OH. When it reacts with the sodium, it takes 2 sodium, this one molecule, and it will give us sodium ethoxide. This is sodium alkoxide, means here ethanol we have taken, so it is sodium ethoxide, and there is a removal of this hydrogen molecule. So this is the sodium ethoxide. So this we call it as sodium generally alkoxide. This is alcohol react with sodium metal, it will form sodium alkoxide plus this hydrogen gas. This hydrogen gas, liberation of this hydrogen gas here. So this is a reaction of alcohol with the alkali metals, that is sodium. I have taken one example. If it reacts with aluminium, so aluminium we know it will form usually when it forms a compound, it will be in a +3 oxidation state. So here CH3, I am taking here tertiary alcohol, that is CH3OH. This is called as, if we go for the IUPAC nomenclature of this, 1, 2, 3, we have to take this chain which is propane, and here at the second position it is having methyl group. So name of this IUPAC name of this compound is 2-methyl propanol. So 2-methyl propane. This OL group is at the second carbon, so it is 2-propanol. And when it reacts with aluminium metal, it will also liberate hydrogen. So here there is a formation of this alkoxide, and this alkoxide will form with aluminium this compound that is called as aluminium tertiary butanolate. So this aluminium, it will react with 3 alkyl group, because alkoxide group, because it is aluminum, always it will have 3 + 3 oxidation state. So to form this, it requires hydrogen. So if we balance this reaction, so here 3 units, so we need here 3 aluminum. So we have to take here 2 aluminum. There is a formation of this 2, so 2 into 3, it means it requires 6 alcohol unit, and there is a liberation of 3 hydrogen gas molecules. So here this is the reaction of alcohol with this metal, that is aluminium. It will form trialkoxide group, the aluminum tertiary butanolate. So this shows that acidic nature of alcohols because of the liberation of this hydrogen gas in every reaction. Esterification reaction of alcohol. When alcohols are heated with the carboxylic acid, alcohols here are heated with carboxylic acid in presence of concentrated sulfuric acid as a dehydrating agent, esters are formed. So this carboxylic acid, general formula RC double bond OH. Carboxylic acid, when it reacts with any alcohol, so general alcohol I will write here OR, it will, in presence of concentrated H2SO4, so sulfuric acid here acts as a dehydrating agent, means there is a loss of water molecule, it removes water molecule and it forms ester. So if these R groups, alkyl groups are different, so we will get here this ester and one remole of this water. This is the general reaction. So this is the ester formation. COR group is called as ester functional group, and this is the alcohol functional group, and this is carboxylic acid. This type of reaction is called as esterification reaction. This carboxylic acid will react with alcohol in presence of concentrated sulfuric acid as a dehydrating agent. Ester are formed here. So this is H2SO4 here. This acts as a dehydrating agent. This acts as a dehydrating agent, means dehydrating agent means it removes a water molecule. It acts as a dehydrating agent. So we will take one general reaction of ethanol when it is heated with this glacial acetic acid, and in presence of ethanol, general reaction I am taking acetic acid, glacial acetic acid, this is RCOOH, that is acetic acid CH3, or ethanoic acid. Glacial acetic acid IUPAC name is ethanoic acid. When it reacts with ethanol, it forms, in presence of saying this dehydrating agent, that is concentrated H2SO4, it will form CH3, C double bond O, this O as it is here, and there is a formation of this ethyl group will attach to this with loss of a water molecule. So we can see here there is a loss of a water molecule, oxygen CO bond cleavage with this alcohol, CO bond breaking of carboxylic acid and OH bond breaking of this alcohol, and there is a dehydration, that is nothing but removal of this water molecule. Same here in case of this reaction of this acetic acid with this ethanol, it will form ester plus water. So this is acetic acid, it is common name, IUPAC name is ethanoic acid. This is IUPAC name, in a bracket I have written IUPAC name. So this is ethanol, commonly called as ethyl alcohol, and here there is a formation of this ester, that is ethyl acetate. It is ethyl acetate or ethyl ethanoate. The name of this IUPAC name of this compound is ethyl ethanoate, and this is a water molecule. This reaction is called as esterification, that is ester formation. So esters usually they will have a fruity smell, and this mixture of these two carboxylic acid and alcohol in presence of acid, it will form a fruity odor compound, that is ester, and this during this esterification OH group of acid combines with the H of alcoholic group forming water here. OH of carboxylic acid will react with H of alcohol, and it will form a water molecule. So in this water molecules, oxygen which is here, it is oxygen will be liberated or removed from this carboxylic acid, not from the alcohol. Reaction is reversible, and therefore water is removed as soon as it is formed. If acid chloride is used instead of carboxylic acid, the reaction is carried out in the presence of base, that is pyridine, to remove HCl, which is formed during the reaction. The shift of this reaction will be towards the right side. So here, instead of taking the carboxylic acid, we can take acid halide. If we take here acid halide here, RCOCl, and this same reaction, I will take general reaction R here, and it will gives us C double bond OOR plus HCl. So this is a reversible reaction with the acid, carboxylic acid, but with acid halide. This is acid halide. It is acid chloride I have taken here. Acid halide, and the chloride is there, so it is acid chloride when reacts with alcohol, and this reaction is carried out usually in presence of pyridine. This is carried out in presence of pyridine. Presence of pyridine, it will give, no doubt it will give ester, but the side product will be a hydrogen chloride, hydrogen halide. If I have taken acid bromide, we will get HBr here, hydrogen bromide. So this is about the esterification reaction of alcohol.